This is the second part of the section 8.2 video. This is all over translating our exponential function y equals ab raised to the x power. Turns out the same process that was used to translate radical functions in chapter 7 still applies to translating exponential functions. As you'll see, graphing our exponential function y equals ab raised to the x plus h power plus k will translate our general form y equals ab to the x by the following units. Negative h units horizontally, k units vertically, and then our value of a here will produce a vertical stretch or shrink. And as we saw in the first part of section 8.2, if we have a negative sign out in front of the value for a, all that's going to do is reflect our general form across the x-axis. So nothing too strange, similar process as for radicals and quadratic functions, but we'll just apply them in a different sense, in a different form, this time with exponential functions. Right, so here's our first example here. Graph y equals 2 to the x minus 30 power and label all asymptotes. Well, first of all, if you notice we have an x minus 3 in the exponent, so what that tells us it's going to be a horizontal shift. It's actually going to be a horizontal shift 3 units to the right, 3 units in the positive x direction. So if you think about what the graph of y equals 2 to the x looks like, we have points at 0, 1, 1, 2, 2, 4, 3, 8, negative 1, 1 half, and so forth. We know what the graph of y equals 2 to the x looks like by now. It looks something like that with a horizontal asymptote at y equals 0. Nothing too abstract there. But now, since we have that x minus 3 in the exponent here, as I said, that's just going to shift our graph of y equals 2 to the x 3 units to the right. So this point 0, 1 will become 3, 1. This point 1, 2 will become 4, 2. This point 2, 4 will become 5, 2. This point 3, 8 will become 6, 8. And likewise for the negative, these points here, at negative 1, 1 half, that'll become 2, 1 half, and we'll have 1, 1 quarter, and so on. Green represents y equals 2 to the x minus 3. And blue here represents y equals 2 to the x. You can see that our function y equals 2 to the x minus 3 also has a horizontal asymptote at y equals 0. All we're doing is just taking these points and shifting them to the right 3 units, since that's our rule in the exponent. We have 2 to the x minus 3. Just shifts every point to the right 3 units, and we can draw our nice curve from there. If you remember, if you want to recall also, think about the domain and range also of this function here, y equals 2 to the x minus 3. Well, the domain, every single x value will be hit. So the domain will be all real numbers. And our range is all values greater than 0. Remember, we have horizontal asymptote here at y equals 0. That's just the line that the graph of this function will approach as x approaches infinity. And that's either in the positive x direction or the negative x direction. In this case, it approaches the line y equals 0 in the negative x direction. So that line, that point y equals 0 will never be hit. So that's why we have to choose values greater than 0 for our range. So next example, we're asked to graph y equals negative 1/3 to the x minus 2. So if you want to think about graphing it, graphing y equals negative 1/3 to the x first, you can do that. And then noticing that since we have a minus 2 at the end here, all that's going to do is take the graph of y equals negative 1/3 to the x and just shift it down 2 units on the y-axis. So in this case, I've already gone ahead and graphed y equals negative 1/3 to the x. So that minus 2 there, all it's going to do is just take all these points and shift them down 2 units. So shifting 0, negative 1 down 2 units, we get 0, negative 3. We shift negative 1, negative 3, we get negative 1, negative 5. If we do the same for negative 2, negative 9, we get negative 2, negative 11. And likewise for the next couple points, we have positive 1, negative 1/3, which becomes 1, negative 2, negative 2 and 1/3, and so forth. Just taking graph our curve, and that is y equals negative 1/3 to the x minus 2. If we come back to our function that we graphed first in blue here, y equals negative 1/3 to the x, we know for that function here, the horizontal asymptote is going to be at y equals 0. Horizontal asymptote for our function graphed in blue is y equals 0. Well, what's going to happen is when you shift that function down 2 units on the y-axis, you're also going to shift your horizontal asymptote down that many units. So in this case, we shifted y equals negative 1/3 of the x down 2 units. So our horizontal asymptote for this function will be y equals negative 2. Just remember, we typically denote asymptotes by a straight dotted line. So all the shift did, the vertical shift, it brought our horizontal asymptote from y equals 0 down 2 units because of the minus 2. And as you see, as x grows in the positive x direction, our graph is going to approach the line y equals negative 2 as x grows, but it will never touch anywhere on that line y equals negative 2. So now let's talk about the domain and range of this exponential function y equals negative 1/3 of the x minus 2. Well, if we take it back to our original function that we graphed in blue here, y equals negative 1/3 to the x, you can see that the domain of that function is all real numbers. And then for the range, we don't have any values, positive values in the range, and we don't have y equals 0 in the range. But we do have all values less than 0. So our range in this case is all values y greater than, y less than 0 in this case. Okay. So just because all the points lie below the x-axis, so our range has to be y is less than 0. And then obviously for the domain, it's all real numbers. And now let's take a look at the domain and range of our function that we were asked to graph, y equals negative 1/3 of the x minus 2. Well, in this case, all it is just a shift of negative 1/3 of the x down 2 units, so the domain will still be all real numbers. But the range is where it gets a little tricky. Remember, for our original function that we graphed in blue, our range was all values of y less than 0. Well, what happened is, with our function that we were asked to graph, y equals negative 1/3 of the x minus 2, we took that function in blue and shifted it down 2 units. So now, our horizontal asymptote is at y equals negative 2, as opposed to originally y equals 0 in our function in blue. But what that also means is, since the asymptote shifted down 2 units, our range will also shift down 2 units and become all values of y less than negative 2. And you'll see, as our function approaches that line y equals negative 2, it's never going to touch it, so the range values have to be all values of y less than negative 2. If you can see that this is a shift down 2 units, and notice, hey, that's going to make our values flip across the x-axis, then you can definitely say that the range is all values of y less than negative 2. So last example, we're asked to identify the horizontal asymptote of y equals 10/3 raised to the x plus 2 power plus 5 and find the domain and range. First, we're going to do it without graphing here. To identify the horizontal asymptote, remember, if we were just to graph y equals 10/3 to the x, we would just get a horizontal asymptote at y equals 0. Well, since we're adding 5 at the end, our horizontal asymptote will be shifted up 5 units, so our horizontal asymptote will be at y equals 5. If you see that, we're just shifting the graph up 5 units, and therefore we'll shift the asymptote up 5 units, then I think you're in pretty good shape. Now for the domain and range. Well, this might be a little bit tougher, but there's no negative out in front, so we know that if we were to graph y equals 10/3 to the x, we'd have all values, all real numbers would be hit. So in this case, doesn't matter what the shift is, we'd still have all real numbers as our domain. And then for the range, well, if you remember the function y equals 10/3 raised to the x, the range of that is all values of y greater than 0. Since our horizontal asymptote's at y equals 0, and all we're looking at is all values greater than, since there's no negative out in front here, we're looking at all positive values. But in our case, we're asked to identify the domain and range of this function here, y equals 10/3 to the x plus 2 plus 5. So all that's going to do is just take the horizontal asymptote, shift it up 5 units, which also will change the range. Instead of the range being y is greater than 0, it'll shift it and be y is greater than 5. And if you need to see it, I'll graph y equals 10/3 real quick. That's y equals 10/3 to the x. And then if we were to shift it, get y equals 10/3 to the x plus 2 plus 5, just like that. And our horizontal asymptote is that y is equal to 5. So you can see, since we shifted it to the left 2 units and up 5 units, the asymptote will shift as well, up 5 units. The domain will be the same, obvious, but then the range will also shift and become all values of y greater than 5.